morning everyone. In this lecture we will learn how to draw the helix curve. So what is the definition of helix curve? Helix is the curve which is generated by the point moving around and along the surface of cylinder or a cone in the direction of axis with constant linear velocity. Okay, so here in the animation you can see how the helix curve is generated. So you can imagine this point, it is moving on the surface of a cylinder. So the point is moving in a circular manner, at the same time it is moving along the axis of the cylinder. Okay, so here you can see for one revolution the distance traveled by the point, so this is called as a pitch of the point or the pitch of the helix curve. So this helix curve, it is used to design the spring, and also it is used in the design of the thread of the screw. So you can see the screw threading. So the basic curve for the threading, it is the helix. Even for the spiral spring, it is designed with the help of the helix curve. So in this animation, this point, it is moving on the surface of this cylinder in a circular manner. At the same time the point is moving along the axis with the constant velocity. So the curve traced by this point, so this is called as a helix curve. Okay, so let us see what is the geometrical construction to draw the helix curve. Refer this first question. So draw a helix for one convolution of a point on a cylinder of diameter 50 millimeter with pitch equal to 80 mm. Okay. So what is meaning of convolution? So convolution means there is one point which is moving on the surface of cylinder and it has a motion which is a circular. So the point has a revolution and plus it has a axial moment. Okay. So combination of circular motion and the axial motion, this is called as a convolution. So for the convolution, the pitch is given, so it is the axial distance traveled. So that distance is nothing but, so axial distance advanced or traveled by a point for one revolution, this is called as a pitch. So that is equal to 80 mm. Okay. Now to draw the helix curve, the first step is draw the circle which is the top view of the cylinder with the given diameter. Next, divide this circle into 12 equal parts. Now take the projection and complete the front view, which is a rectangle for the cylinder, and take the height of the cylinder equal to the 80 mm. So the pitch given, it is nothing but the height of the cylinder. Now complete the rectangle in the front view. Now select one point on this horizontal line. You can select at 1 or 2 centimeter. Okay. Now from this point, take the length on this line which is equal to the perimeter. So as phi is 50, the perimeter is 2 pi r or pi d. So this is approximately 157 millimeter. So take the distance 157 millimeter. Now divide this 157 millimeter line into 12 equal parts. So you can use the geometrical construction, draw one line. Okay, so in this way we can divide the line 157 millimeter into 12 equal parts. Now name this part starting from P. So P means it is the initial position of that point which is moving on the surface of the cylinder. So here I have selected the P point on the extreme left side. Okay. So from this position the point will start its rotation in the anti-clockwise direction, and then it will complete the one revolution or one convolution. Now from this point draw the parallel line. And from each point draw the vertical line. So join these two corners. So it is the diagonal for this rectangle. Now from this point 1, 2, 3, 4 draw the vertical line that will intersect the diagonal. Now from all the division of the circle take the vertical projection. And from these intersection points with the diagonal draw the horizontal line. Now name this point. So now we have to draw the helix curve on this cylinder. Okay, so this is the front view of that cylinder. So if you observe the top view, so we have selected this extreme point on the left side as a starting point. Okay, so P is moving in the anti-clockwise direction like this. So P, it will gradually shift in the upward direction. So this is the initial position. After this point will shift at this location. So again after 1/12th revolution this point will shift at this location, okay, and so on. So we will mark this intersection as P1, P2, P3, P4. So this is the P1, this is P2, then this is P3, this is P4, so after half revolution the point P, it will shift exactly on the right side. So this is the 6th position of the point. So in this way, mark all these points. Now as the point P in the top view is moving in the anticlockwise direction, so if you observe from this direction, this is the front view, then for half revolution we can see the point, okay, because in the front surface of the cylinder, okay. But for remaining half revolution, point is behind the cylinder, okay, so that surface is not visible. So half part of the helix curve is visible to the observer and remaining half is hidden for one complete revolution. So connect all this point by a smooth curve, which is the visible line. So you can see here, this is the first half revolution. So this curve is visible, okay. For remaining half revolution, curve is not visible. So connect all this point by visible line, and remaining half portion of the curve, it is a hidden curve. So join this point by dotted line. So this is the complete helix curve for one convolution, and this angle, this is called as a helix angle. So sometimes in the problem, this helix angle is given instead of the pitch, okay.